Good morning to one and all. Myself, Dr. Ganesh Miriyala. I'm the assistant professor in the Department of Electronics and Communication Engineering in the Department of ECE. And in the last lecture, we have studied about the signal, general basic types of the signals. Now, in this lecture, we are going to be study about the operations on signals. So, if you look into the operations on the signals, there are 9 types of operations we are going to be do in the signals. The first one we can say it as a amplitude scaling. So amplitude scaling, next one it is amplitude shifting, and one is addition. We are doing with the addition with the signals, and one more thing it is multiplication and differentiation, and the next one integration. So these are the some basic operations. These are not that much important in your academic section point of view. When it comes to the gate and academic section point of view, time shifting and time scaling are the most important. Time scaling and as well as the time reversal are the most important things for the academic as well as the gate. So for your only academic point of view, you can see only the first 6 plus 3. So these 9 are the we are going to be looking into for next couple of minutes. And the first one, amplitude scaling. Amplitude scaling means, if you just look at here, if you take any signal, let x of t, and sorry, you can take it as a x1 of t and x2 of t, 2 are the signals. As well as these are the in the continuous domain. If you look at the x1 of n and x2 of n in a discrete domain. So these two are the two sets. One is in a continuous domain and second one is in a discrete domain. This is a continuous domain. So according to the amplitude scaling, how we are going to be amplitude these two signals. Let us say I am defining some y1 of t. This is a y1 of t. I am doing some scaling with the signal like some constant a or k or whatever it may be. For instance, I am taking some constant a. So scaling means I am multiplying this signal with some constant x1 of t. Now similarly, like x2 of t. If you take y2 of t, now the signal is multiplied with some constant b into x2 of t. These are the amplitude scalings. We will look at it in the graphical wise also. Similarly, if I take y1 of n, then my signal look like a into x1 of n and y2 of n, and the same signal I will take some constant b of n into the x2 of n. If you look into the graphical wise, if I take one signal like this, this is my x1 of n. x1 of t. If I take this is a x1 of t, let us take this is a x1 of t. Now it starts from the 0 to 5 time constants. Now the amplitude is take it as a 2. So for this signal, if I want to scale by a units of a, some that a units is equals to now 10. A equals to 10. So for this one, I need to write the signal y1 of t is equals to some constant whatever we are taken, it is a, that means 10 into x1 of t. So 10 into x1 of t. For this signal, so graphically how we are going to be represent the same signal, we are going to be represent in terms of with respect to t. This is a y1 of t now after scaling with the units of 10 units. Now my signal is look like same, but the amplitude is going to be multiplied by 10 units. Now this is a 0 and this is a 5. This time interval is not going to be changed. This is no change in time, and but the amplitude whatever we are taking, this is a now 10 multiplied by your original signal. What is the original signal? You have 2 units. 2 into 10, that is 20 units. Now your y1 of t has the magnitude of or amplitude of 20 units. So this is about the amplitude scaling in continuous domain. When it comes to in discrete domain, if I take some signal like this is the 0 location, this is the 1 location, now this is the 2 locations. So simply signal is moving like this, and this is the time interval. Now signal name it is x1 of n I mentioned. So for the same signal, if I want to represent in a time scaling, let us take y1 of n. I have taken it as a some 9 into x1 of n. So your amplitudes are going to be, let us take this amplitude is 1 1 for each and everything. Now your amplitude is going to be changed. No time changes, that is 0, 1 and 2 as it is, and your amplitudes are multiplied by the 9 factor. That means then is a 9, 9 and 9. Initially you will have the amplitude levels are 1, now your amplitude levels are 9. So this is about the amplitude scaling. This is the first unit. Sorry, first classification. Next it is a amplitude shifting. So how we are going to be shift the amplitude. So same signal, let us take x of t is one signal. X of t is a continuous signal. Now I want to represent y of t. So y of t is a after shifting. I am taking y of t is a after shifting. Now this is a with respect to t units. So this is the original signal. Now shifting means we are adding some constant. Shifting means we are adding some constant to the original signal. That is, if I take same signal, this is the amplitude of the signal. Let us say this is a u of t. I am taking this is a u of t with respect to time t, 0 location, amplitude is 1. So this is the u of t. Now if x of t, my x of t is equals to u of t. If x of t equals to some u of t, I want to shift this signal. So what is the location it is going to be shifted? It is now write it as a y of t is equals to some constant. Let us take that k is equals to some 5, then plus x of t means it is a u of t. So this is the shifted signal it is. This is a shifted signal. Then how we will represent this in a graphical domain? This is time t. Shifted means initially the amplitude is at 0 and now your signal will be shift with respect to 5 units. Let us take this is a 5. Now 5 onwards your signal will be 1 unit. From the 5 onwards it will takes the 1 unit. That means you will get the 1 unit. So it may be it's look like some equal to the scaling point of view, but if you take some another signal, let us take I have one sinusoidal signal. Let us take the sinusoidal signal. This is sinusoidal signal and name it is x of t. Now my response with some constant 0 amplitude over 5 to minus 5. If this is the original signal. Now if I want to shift by 10 units, let us take it as a 5 units. If I take y of t which is defined as some 5 plus x of t, that means 5 units. Initially midpoint is 0, right? Now the midpoint will move to the 5 units. This is a 5th line. I mean amplitude is at 5 line for this signal. Now 5 plus 5 it is 10, 10th line, and it is 5 minus 5. This is a zeros line. Let it be like this. So your signal will be looks like this. So that means see the 0 line is here midpoint. Now the 0 line for this signal is now at the 5th unit. That means the distance from here it is 0. Now it is from the 0 to 5. The distance is 5 units. That means the shift in amplitude is changed from the 0 to 5 units. 0 to 5 units. So this is about the amplitude shifting. Next, addition. Addition of the signal means, so we are just adding the two time domain signals. One is x1 of t. Let us take, I am defining x1 of t is one signal and x2 of t is another signal. So these two are the two signals which are available in our hand. So I am defining some new signal y of t which is nothing but the x1 of t and addition x1 of t plus x2 of t. x1 of t plus x2 of t. This is called the addition. If you take in a discrete domain, y1 of n is equals to x1 of n plus y1 of n. x1 of n plus y1 of n. Let us take the same kind of signals. I am taking one is the u of it's a rectangular function from the 0 to 5. The amplitude is 1. This is a x1 of t I am taking. Next, another signal I am taking. It is a exactly in between. Let us take it as a 2. This is another signal. I am taking it as a x2 of t. So these are the two signals. This is u of t minus 2. So we will check this signal in later, but take these two are the two signals. And what is the addition of these two signals? Addition of these two signals. Now look into here, from the 0 to 5 the amplitude is 1. 0 to 5 the amplitude is 1, whereas from the 2 to infinity time interval, now your amplitude is 1. That means the amplitude is 1. So if you add these two components from the 0 to 2, so this is a value is 0, this value is a 0, and this value is a 1. Then 1 plus this 0, you will get the 1 value. Up to from 0 to 2. From 0 to 2, you will get the 1 value. Next, from the 2 to infinity, so again you will have the drop over there. Now from the 2 to, let us take it as a 5. This is value is a 5. This value is a 5. So from the 2 to 5, you will have the 1 plus this also 1. 1 plus 1. You will have the amplitude is 2 at this position. You will have the amplitude is 2. Now from 5 to infinity, from the 5 to infinity, you will have 0. Here it is 1. 0 plus 1. Amplitude is 1. So this is the resultant signal. From the addition of the two signals, it is, you will get, like, let us define it as a y of t. Now y of t is a sum of the two signals. That means wherever the time axis we are taking, this time axis values, time changes. From the 0 to 2, it is constant. 0 to 2, it is a constant, it is 1. And after 2 to, both are changed. So first one is not changed, then here it is changed from 0 to change. So 0 to 1. So this changed locations are the important. Here it is, these are the change locations. 1 to 0, here 0 to 1. So you will have the resultant signal y of t like this. This is about the addition of the signal. Now multiplications. So multiplication means it is directly simply same, x1 of t is a one signal and x2 of t or the another signal. Now your multiplication of the signal y of t, we can define it as a x1 of t multiplied into x2 of t. Same, you can take the same kind of signals. So just take, this is a x1 of t in the interval 0 to 2, like amplitude is 1, and take the another signal 1. This is directly u of t, that is equals to x2 of t. Amplitude is 1. Now this is the time t. Now your resultant signal will be look like what? See, again check the amplitude changes, where the amplitude changes is happening from the 0 to 2. From this one, amplitude is 1, 0. 1 to 0 it is changing. But what are the time intervals? At a time interval 2, this is happening. That means take the dot line from 0 to 2. So you just look at here, from the 0 to 2, both amplitudes are 1. This is a 1 and this is also 1. So multiply these two, 1 cross 1, that means you will get the 1. Amplitude is 1. After that, you will have the amplitude is 1 over here, and at this one you will have the amplitude is 0. 0 cross 1, the amplitude is 0. So that this is the signal, 0 units. This is y of t. So like this, we are going to be multiply the signals x1 of t and x2 of t. This is the about the multiplication of the signal. Next, differentiation. Differentiation means you can say same x of t is one signal, and I am defining some y of t signal with respect to the x of t. How you are going to be differentiate the signal? Then differentiation means d by dt of x of t. D by dt of x of t. Or in a higher order, you can say it as a d square of x of t by dt square. Or if you go for the higher order, and d power n into x of t by dt power n. These are the definition of the differentiation of the signal. So for this one, let us take some signals r of t. R of t means it is a amplitude is t for the t greater than r equals to 0. This is a ramp signal. If you differentiate the ramp signal r of t, d by dt of r of t, that is equals to d by dt of t, which is equals to 1. 1 is nothing but it is a u of t. It is a unit step function. Then similarly, d by dt of t square, that means a parabola function. So I can directly say it as a t square. Then d by dt of t square, I can take it as a 2t. Again it is 2 into r of t. This is a, again it is a ramp function. This is about the ramp function. So this is about the what do you call, differentiation of the signals. So again one more thing, you can take it as a d by dt of parabola p of t, which gives the r of t. I'll write here d by dt of p of t, parabola t, you will get the r of t, and d by dt of r of t, which gives the u of t, again d by dt of u of t, which gives the del of t. These three are the most important things in a signal processing and signals and systems for a differentiation point of view. Next one, integration. So integration for the x of t signal, I will defining y of t, which is equals to integral minus infinity to tau x of tau d tau. Integral minus infinity to t x of tau d tau. If you do this operation, you will get the integration of the particular signal x of t. Let us take same one. If I take del of t is my input. Now your y of t, you can take minus infinity to t del of tau d tau, which stands for the integration of del of tau is nothing but it is a u of t. Now same, if you do the same, y1 of t equals to, with respect to minus infinity to t, u of tau d tau, which gives the, generally u of t, if you do the operation on u of t with integration, you will get the r of t. So if I take a y2 of t, which is equals to minus infinity to t, then r of tau d tau, which gives the parabola signal, it is p of tau. So this is about the integration of the signal. So in summary, we'll check it what we have discussed in today. One is a first one, it is amplitude scaling and amplitude shifting, and the next one one is addition, next multiplication, next one we are saying it as a integration, right? These are the operations which we have studied in the last few minutes. And the next topic, we will discuss the next levels, that is time shifting and time scaling, and next time reversal. So these three things which are the important, these are only for the academic point of view only. Now these are the important for the academic as well as the gate.